Hello everyone. As you can see, I'm on the Microsoft Azure ML Machine Learning Studio page. So I'll quickly summarize what I'll be covering here. Today I'll be showing you a multi-class classification model, and through that I'll be conveying you an important message that how important it is to use right set of features whenever you are performing a machine learning model. And the next thing which I'll be showing you is how to consume two-class classification algorithms on a multi-class dataset. For example, there are many two-class classification algorithms in Azure ML, like two-class boosted decision tree, two-class neural networks. So I'll be showing you how to consume those algorithms on a multi-class dataset. So let's get started here. First of all, go to studio.azureml.net and sign in. Everyone should have a free account up to a certain limit which Microsoft allows, and I'm signing in here with my account. And while it's signing in, I'll show you the dataset which I'm using here. It's from kaggle.com/uciml/class/data. So this is the class dataset. You can download it from here, and it contains different class attributes, and then based on those attributes it's identifying the types of class 1, 2, 3, 4, and so on. So here I have logged into my Azure account. I'll upload the dataset by clicking on new and then go to dataset, and let's upload that class dataset which we downloaded from the Kaggle website. Here it is, class.csv. So while it's uploading, I'll get started with my experiment. So experiment is where we make our machine learning model in Azure ML. So here is my experiment. I'll just quickly rename it as multi-class classification, and my save dataset, you can see in the save dataset, and my datasets, as you can see, it's here class.csv, which I uploaded right now. So let's visualize this dataset. Okay, so this is our dataset, and as you can see, these are the different attributes of class, and until from Ri to Fe is the components of class, and this is the type of class based on those components. So we can visualize that none of this has missing values, so we don't need to bother of missing values. And then this is the class type, so there are 6 unique values, so there are total 6 different class types here. So if you go on the class dataset description, you'll see that here it's mentioned that class dataset find 5 is not found in the dataset. So that's okay, we'll have 6 different types of class, and then we'll be classifying classes on this 6. So first of all, since that class type is categorical, so let's make it as categorical by using edit metadata module. Connect here, and then just click on launch column selector, and then just select type and change it to make categorical. That's it. So since there's no missing values, we don't need to bother about any imputing missing values, and let's just split the dataset now straight. Okay, so let's split into 70-30 ratio. So 70% of the data will be going towards the training, and the 30% will be for testing the results based on the training. Okay, so let's use a multi-class classification algorithm here. So as you can see, AzureML provides 4 multi-class classification algorithms here. So let's use multi-class decision forest for now, and then use train model module to train the model. Let's connect multi-class decision forest to train model, and then the 70% data set for training. And let's put a label as the target, and which is type. This has to be done every time. This type is our target variable, which we need to mention in train model. Now let's score the model. Here we'll be using the training results, and we'll be also importing the 30% test dataset to test how impactful our training results are. And then for evaluating all this, we need evaluate model module, which will connect from score model. So that's it. Let's run the model. Okay, it's running. Okay, so our model has finished running now. Let's see the results. I click on evaluate model visualization, and then as you can see that our model has obtained an overall accuracy of 67% here. So it's not that great, not that bad as well. And as you can see here, we have classified our different class types here. So the number one class types has accurately been classified. 68% of the one class type has been accurately classified, and type 7 has been accurately classified as 85.7%. So this also you can visualize here. So the one takeaway here is that our overall accuracy is 67%, which we should remember for now. So let's see how we can improve this accuracy by going back again to visualize the dataset. Okay, so here we see that it's all continuous numerical values in each of the features, and it has unique values as 94, this has 118, so it's all good. It's 133, 65, it's all good. It's 143, it's fine. It's 34. Okay, so as you can see here that the BA has BA chemical element has a maximum of zeros, which seems suspicious, and I think we should get rid of it into the BA column. So let's go to it, and and in fact FE as well has a lot of zeros. So let's remove BA and FE both and try whether we can improve our accuracy or not. So for that, let's select the module select columns in dataset. So we'll be fitting this module in between edit metadata and split data. So let's connect it metadata to select columns in dataset, and then in select columns in dataset, go to launch column selector, and with rules, and then go to all columns and exclude BA and FE. These were the two different elements which we decided on. Okay, then everything should remain the same. Let's run it again and check whether our accuracy improves or not. As you remember that earlier our accuracy was 67%. Let's see how much we have improved or how much we haven't improved. Okay, our model has finished running. Let's check the results. Okay, so our model hasn't improved. In fact, it is reduced from 67 to 65%. Okay, let's make further changes. Let's include FE and just exclude BA element, and then check how better our model becomes or how worse our model becomes. We'll check once our model finished running, and then we'll just visualize the results in evaluate model. So as of now, we have just removed the BA chemical element. Okay, so our model has finished running. Let's check the results. Okay, so our overall accuracy has increased from 67% to 70% now. So this is a good result. So this works. By removing PA element, we have increased our overall accuracy quite a bit. Okay, so this was a way to show that how important it is to use right set of features and spend time on understanding the features which can be relevant in context of the business and the target variable as well. So we have achieved a 3% increase in the overall accuracy. Significant increase it is. Okay, so this was the thing which I wanted to convey with the importance of using right set of features. The next thing which I'll be showing you here is to try different multi-class classification. Also, you can try different multi-class classification algorithms to check which is giving the maximum accuracy. For example, I just use multi-class decision forest here. You can use different multi-class classification algorithm to check if some gives more accuracy. Okay, so the next thing which I'll be showing you is using two-class classification algorithms for multi-class datasets. So I'll just delete this multi-class decision forest, and then I'll just use two-class boosted decision tree, for example. I'll take here two-class boosted decision tree, and then last year a new method called one versus all multi-class was introduced in AzureML. One versus, if you search here, yeah, here we go, one versus all multi-class. So those are introduced in AzureML to work with present two-class classification algorithms. And one versus all multi-class method forms an ensemble of binary classification models. So remember, one versus all multi-class needs to have a two-class method always to work on. We can use one versus all multi-class module to classify for multi-class target variable then, like we'll be doing here. So let's connect two-class boosted decision tree to one versus all multi-class, and then one versus all multi-class to train model. Okay, and just run it. Okay, so remember the earlier accuracy was, overall accuracy was 70%, the maximum which we achieved earlier by removing the BA chemical element. And here also we have removed the BA chemical element, we are not keeping it, and we are just running a two-class boosted decision tree. And then let's check whether we can increase the overall accuracy or not. Okay, so our model has finished running. Let's check the results. Okay, so our overall accuracy is 82% now, so it's quite a big increase, a significant increase in the overall accuracy. Earlier it was 70% and now it is 82%, so which is quite promising. So yeah, we are able to get more better accuracy compared to above cases which we discussed earlier, and hence implementing different algorithms and using the right set of features is the key to train our model in a better and accurate way. So that's it for now. All the best, and maybe this helps you in creating your next multi-class classification algorithm and achieve a higher accuracy in your own dataset. Thank you so much.